Hi all, we welcome you all for the today's podcast session. So if everyone can turn on the videos, it will be great.
Yeah, I think we can get started.
Yeah, okay. So hi all, good evening. So we thank you for joining today's session as you're showing some interest in learning new technologies and joining our session. So thank you everybody. So we welcome you all for today's VodQA Shorts 15th edition of Coimbatore. So, and we will give a quick introduction on myself. So myself, Subhajyoti. So I've been working as a quality analyst in ThoughtWorks for about 6 months, and I have a total of 6 years of experience. And I have Monika along with me, so who will be hosting with the today's event. Yeah, Monika, you can introduce yourself.
Yeah, thank you, Shubha. So, hello everyone, Punita here, and I'm a QA in ThoughtWorks, and I have been with ThoughtWorks for around 1.5 years, and I'm having around 5+ years of experience in testing. Yeah, over to you, Shubha.
Yeah, thank you, Monika. So yeah, today we'll have set of agendas today to speak. We have speakers also along with us. So, and also the one more thing we have added in today's event is like we have a quiz after each talk. So you will get a polling of questions in the chat. So you can please attend the quiz, and the winners will have an exciting goodies. So we request you to all participate and win your goodies. And before starting with the topics, we have Premnisha with us to give a welcome note. So Premnisha has started in ThoughtWorks before 4 years, and she has started as a developer. And now currently she is playing a role of community lead for the Coimbatore office. So yeah, over to you, Premnisha.
Thank you. Thank you for that quick introduction. Welcome everyone for today's VodQA session. So I'm not sure how many folks, is anyone attending VodQA Shorts for the first time in the group? All right. Quickly about VodQA. Okay, quite a bit of folks. Great to see the numbers. Thank you for the raise of hands. So VodQA is primarily an external event that's run by the ThoughtWorks QA community that to ensure there's a whole bit of learning and sharing that's happening, not just within ThoughtWorks, but is also shared with the larger community outside. And this is one of the ways where we express thought leadership. This forum was started with the motive of, come together, learn something new and share perspectives. That was the motive. And there's a forum open for everyone to come and share, present their ideas, share your perspectives and your learnings on various topics. And today we'll have three topics that will be presented. API test automation using the Karate framework by DDD approach. That will be presented by Manoj, Karthick, and Vishwaja. Test strategy for chatbot will be presented by Monika, Sharma, and testing cloud native applications will be presented by Lipika. Should I go ahead and introduce the speakers as well? Shubha, Punita.
We'll introduce.
Okay.
Everything is.
All right. Then hopefully we all have a great learning session today. Welcome everyone again.
Yeah. Thank you, Premnisha, for welcoming. And once again, we welcome you all for the VodQA Shorts 15th edition of Coimbatore. So as Premnisha mentioned, we have three topics today to discuss. And before moving on to that, we just wanted to share something. So we hope you went through the mail and meetup pages for the VodQA event. And you can follow our forum, ThoughtWorks VodQA Coimbatore page as well. And we'll also share the link in the chat. And you can watch out the space for upcoming events as well as previous sessions as well. So yeah, we'll move on to the, any questions or any doubts so far? Okay, we'll take the test now. Yeah, we'll get started then. So our first topic is API test automation using Karate framework by BDD approach, which will be given by two speakers, Manoj, Karthik and Vishwaja. So yeah, Manoj Karthik, he is a senior QA around 7+ years of experience, and he is associated with ThoughtWorks for a year. And he is passionate about test architect and working in various tools and tech stacks like Java, JavaScript, etc. And coming to Vishwaja, she joined ThoughtWorks 6 months ago and working as a QA. And she's interested in UI automation and exploring more on testing tools. Yeah, over to you, Manoj and Vishwaja.
Yeah, sure. Thanks, Monika, for giving a brief introduction about us. Hi, people here. So this is Manoj. So I have Vishwaja here. Vishwaja, you can just give answer to the audience.
Yeah, hi everyone.
So maybe I just share my screen. So you are able to see my screen.
Yeah.
So, hi folks, today we are going to present one interesting topic on API test automation using Karate framework by using a BDT approach. So most of us, you would have been aware of doing an API test automation using REST assured or using some other Java HTTP client. So you would have not aware much about the Karate framework. So there is a framework and dependencies which has been developed by one of the folks in the Karate labs. So for automating everything in a simpler way. So if you're using a REST assured or any other platform, you'll be needing some kind of code dependencies to doing it. So, but if you're using this Karate framework, so you can just write a simple code in a BDT approach. Using a Cucumber format. So that's what we wanted to showcase this one today as part of this session. So maybe I'll move on with the agenda. So these are the topics which we are planning to cover today. So first we will be seeing an introduction to Karate. So and then we'll be looking at the Karate working architecture. So the internal platforms. So Karate has been developed on top of any other framework which was available in market. So then we'll be looking at the framework components. So for automating the API test using Karate. So then we will be seeing future files and test runner. So as I mentioned that it's a BDT approach. We need a future file for API test. So then we'll be see how this API test automation works in the platform by having a live demo. So and then we'll look at the key features. And then we'll see what's the difference between Karate, REST assured, and the Cucumber framework. At last, we'll see what are the advantages of using Karate. So without any further delay, maybe I'll hand over the session to Vishwaja to continue.
Thank you, Manoj. So let's move on to introduction to Karate framework. Karate framework follows the BDD style of writing the program, which follows the BDD approach. The syntax is easy to understand by any non-programmer. And this framework is the only API testing and combined API test automation and performance testing into a single skeleton tool. It provides the user that the ability to execute the test case in parallel and perform the JSON and XML checks. It supports automation for REST, SOAP, and GraphQL API services. So let's move on to Karate architecture. So this Karate architecture is built top of the Cucumber framework. And as I already mentioned, it is easy to understand by any non-programmer. So here, Cucumber JVM, Java Virtual Machine. So it's glued with the step definition and a feature file. But in Karate, we are having only feature file. So Karate DSL interpreter are sending the HTTP client abstraction request and getting the response by Apache and Jersey. Then JS engine helps to execute the code of JavaScript with JSON and XML checks. Here, the data functions means put, patch, post, etc. The whole Karate script is running in Java runtime environment. And the JUnit runner helps to run the script. Once the script is running, once the script is executed, then report will be generated. So let's move on to next slide. So these are some framework components. Karate dependent libraries. So first, while writing the script, we have to import some libraries. After that, Karate API test scripts. We have to write some API scripts, then test runner using JUnit. So we have to import one library name as the JUnit to run to execute our script. Once our script get executed successfully, then report will be generated. How many test cases are passed and failed report will be generated. So let's see. Can you please move on to next slide? So this one is the feature file. So we'll consider one scenario, create and retrieve a cat. Given given and when, then, and. So this is the Gherkin keywords. So here in the first scenario, we are passing the method as post and status as 201. That is payload assertion in one line, ID is not null and name is Billy. So in the second scenario, we're getting the path as a response ID, method as get and status as 200. So let's see the test runner file. So here we are importing one package name as the animals.cat and importing two libraries and giving the annotation like run with. To deep understanding, I'll hand it over to Manoj to continue with demo.
Yeah, so maybe before going ahead with the demo, so let's pass on for a minute to check from audience side if there is any clarification on the slides which has been explained now the expression. So we want to know what is the karate or any other things. So if there is no further questions, so maybe I'll just show you the demo. So the karate framework works for automating the test API things. So in order to demonstrate the API test automation using a Karate framework, so we have taken a Maven project. So wherein, as Vishwaja mentioned that you need to import the Karate related dependencies in a form.xml to consume the Karate services for the test automation. So in a form.xml, we are adding both Karate related dependencies and JUnit related dependencies in order to execute our tests. So these are the two things which will be needed to get started with the API test automation by Karate. So then, as mentioned before, this is a kind of BDD approach for automating the API test, so that we will be having only future files kept in our main project. So we are having the future files under a future package and test folder. So under future package, we will be having a different set of a future file specific to the get API calls or a post API that future file. So whatever it's there, so we are following the same structure pattern. So if you see the get API that future file, so here we are having a list of test scenarios grouped for testing the get API calls. So here we are defined in the same pattern. So we will be doing it in a Cucumber BDD feature file. The same approach we will be following here as well. We will be having the scenarios grouped under the feature file. So here we will be having one tag called as background. So this background is nothing but it's pretty much similar to the before test annotation in test.ng. So one variable will be initialized every time. So when you run a successful test in the same way before executing every scenario, so whatever the value you are defining in the background session, it will be get initialized. So this is nothing but similar to the setting of the base URL in any framework. So here I'm just setting my API endpoint URL to be pointing to this value. So then if you see the first scenario, this is nothing for getting the details of a user with the header. So here I'm representing my test scenarios in a Gherkin's keyword. So using a given, when, and then. So then I'm using a Karate keyword such as path. So using a path, I'm initializing the actual path of the API. So for which I need to test it. So then I have to mention which kind of method is it. So for now, I'm just going to validate the get API call. So that's why I'm using the Karate keyboard method, and then I'm making my API assertion value to be as get. So then if you want to pass any headers for your API request, so if it's a kind of single header, you can make use of this header keyboard. So then you can pass the header value along with the information. So then if in case if you want to have multiple header values for your request, so you can make use of headers keywords in Karate. So this keyword will be accepting the input variable containing the list of header values. So you can see that request underscore headers having multiple values defined in this line number 11. So wherein all of the header values, so whatever I mentioned, the line 11 will be picked up and passed to my request. So then I'm just checking my status is to be as 200 OK success or not. And then I'm printing my response using the keyword method. So these are the things for printing the response and response status and the response time. So this is how you can write an test automation code using Karate in order to test the API test. So here I am not using any Java code or a separate step definition file in order to write my API test. So instead, I'm using only the methods. So whatever it's available in the Karate, so then I am writing my API test. So if you see in the scenario, so here we are retrieving the details of a user with parameter and assertion in the API response. So if you want to add any kind of parameter for your API request, in Karate, we have one keyword called as param method. So using this param method, you can pass the filter values per page. I'm passing it as 6. So then the remaining lines is the same, whatever we are seeing now. It's a get API call, and then I'm passing the values and printing it. So then I'm making use of match and assert method to check whether my response JSON object, so whatever it's fetching from my API is as expected. So here in this line using match, I'm just checking my first name in my response is not equal to match. So then I'm just checking my response length is retrieving the length of size of object 6. So because I'm making a filter here using a parameter as 6, then I'm just checking and ensuring that the response is retrieving only the JSON limit up to 6. So if you see the next scenario, so here it's getting the details of the user with some conditional logics and loops.
Manoj, sorry for interrupting. Can you check your mic, please? Can you come to closer to your mic? Yeah, please.
Able to hear me?
Yeah, it's clear now. Yes.
Sure. So this is a scenario for getting the details of a user with conditional logics, checks and loops. So as I mentioned that here we are not using any separate coding logic or step definition file to write your API test. If you want to add some kind of a iteration logic or some kind of a conditional if and else checks, so still that is also possible in Karate. You can make use of JavaScript to be perform this validation. So here in Karate, we can make use of eval keyword to execute your JavaScript logic. So here we have mentioned the loop iteration for iterating through my API response. And then I'm just checking it whether my length of API response is as expected equal to 6. So if it's not expected, in else condition, I'm just making my Karate test script to be failed using Karate.fail invalid response. So this is how you can make use of JavaScript in Karate script for performing conditional logic checks and looping. So then the next scenario is for retrieving the details of user with either authentication token. So before going into this scenario, so I would like to mention that Karate supports code reusability also. So in most of the cases for fetching token information, so this will be needed in each and every test in the header authorization information. So I have kept this token generation test scenario in a separate feature file, user authentication.future. So in this feature file, the scenario, whatever I defined is fetching the token for user detail. So every time this particular scenario will be returning the token response. So token response which is needed in order to proceed with my API authentication. So you can make a call of the particular token generation test scenario from the future file user authentication.future using a call and then read method in a Karate. So it's a kind of simple method call from one class to another class. So we can also call the particular test scenario from one future file to another file. So after calling, you'll be having an content, the token available in the response JSON object. So then in this response variable, we can access the access token. So then we can concatenate it with the header for making my authorization available for the API endpoint. So this is how you can reuse some piece of code from one future file to another. And also the authentication also it's possible in Karate. So you can just simply pass that authentication token in authorization header value. So this is pretty much about automating the Git API scenarios using Karate. So next I'll just show how we can automate the post API call. So this is also similar to the Git API thing. So only difference here you need to pass the request payload. So in the line number 9, I'm just using a request keyword. So in the request keyword, I'm just passing the payload information. So for which the resource needs to be created in a database. So then my method, I'm defining it as a post. So then I'm just checking my status to be validated as 201. So this is how you can automate the API calls as well. So in this scenario, I've just directly upcoded the JSON information in the request payload and in the response payload as well. So if you would like to fetch this request payload information and the response payload information from a separate JSON file, so that one also it's possible in Karate. So in the second scenario, you can see in this line, I'm using pointing my file path of the variable from the data package. So in the data package, so I'm keeping two kind of JSON information. So this is for my request payload information, name and job, I'm adding it. So and then the response payload information, I'm having a certain kind of validation to be available. So the same JSON information, so I'm invoking in my code using a read method. So and then I'm making a request call without directly hardcoding. I'm making a call to JSON using read method from external files. So then in the response payload validation as well. So instead of hardcoding, I'm calling my JSON information from the external files. So this is how we can automate the post API calls, and you can call the respective JSON information from the external files. So then using Karate, you can automate the GraphQL service as well. So till now I've shown only the REST API calls. So we have seen REST API automation for the GET calls and the post API calls. So but using Karate, you can automate the GraphQL service as well. So as we know that you will be passing a query. So in order to retrieve some information for GraphQL services from the endpoint. So here in the request information, I'm just passing the query, the jobs ID and title. So I need to fetch the response using this GraphQL endpoint. I need to fetch ID and title only. So then it will be a kind of post call only every time. So then I'm just checking the status validation. So again, using JavaScript, I'm performing the iteration to the response and checking that title is not equal to null in the response information using match class. So this is how you can automate the GraphQL service as well. So then at last, you can connect to database as well. So in most of the times when we do our API test automation, you need to validate certain kinds of values from your database. So using a JDBC driver in Karate, you can connect your particular database. So here I have configured to connect to my local Postgres SQL database. So here I've just maintained the conditional checks, the username, password, and other credential information of my local DB. So then I'm pointing my Karate script to my local DB and I'm fetching the required information. So in this line, you can see that I've created an instance of a DB in variable DB. So using this DB instance, I'm reading the particular rows. So the queries, whatever we need to pass it in a database, I'm just passing it here, select star from employee. And then I'm just storing the results of the particular query in the employee variable. So then I'm just checking whether the employee is having the right information or not using a match keyword in Karate. So this is how you can simply connect to your database and do the database validation along with the API test validation as well. So then coming back to the test execution. So as mentioned by Vishwaja, we will be needing a test runner. So in order to execute our API tests, so this is nothing but the Karate test annotation, we are using it. And then we are just mentioning the run keyword to execute our test. So two kinds of execution is possible in Karate. So one is sequential mode of execution. Another one is parallel mode of execution. So let me try to execute a sequential way first. So whatever the feature files we maintain in your future package, so everything will be get executed one by one in a sequence. So as of now, you can see all of the feature files is getting executed one by one. So whatever I maintain in the future package. So this will be done in a sequential manner. So we are not using any other logics to do it. I think here one of the service was taking time. So maybe I'll stop the execution. So now you can see the execution was happening one by one without any interruption. So if you want to perform this execution, everything in a parallel mode. So again, using a JUnit test annotation, and then you can define the parallel count. So how many parallel counts? So for example, if you want your test execution to be happened in 6 parallel thread counts, so then you can define the thread counts using the parallel method. So here I maintain the thread count to be a 6. So when I execute the test now, so all of the API tests, so whatever it's available in my future file, so everything will be executed in a single shot. So without any sequential approach, all will be run in a parallel way. So by creating 6 parallel threads in a parallel. So this is how you can do an execution in Karate in sequential and the parallel way as well. So maybe this was having some issues. I'll just stop it. So once the execution is done, a test report will be generated under the target folder. So Karate is having a inbuilt test generation pattern, so that if you want to customize your test report also, you can, that is also possible in Karate. So, but it has a default test generation approach as well. So I'll just open one of the test execution report. So this is the report which has been generated recently. So here you can see the detailed scenario. So whatever we mentioned in the particular future file, so everything will be get printed. So here create user details. So in a background, we have just mentioned that URL value to be passed as this base URL path. So and then we have just checked a few of the detailed information as well. So those things also it's available here. So and in the API response, so we have maintained one kind of values to be get printed. So those response, complete API response will be get printed. So at later point of time, you can come back to this report and you can verify your test execution report. So this is one of the another added feature for Karate. So it's easy for debugging. So in case of any failures, still the particular step will be highlighted in Karate report. So as of now, you can see in this report, the step 5 is getting failed. So the reason for is that the expected status was 200, but we have retrieved the status as 201. So that's why this particular step has been failed. So even in case of test execution failure, you can just directly look at the failed steps and you can just check. So what's an issue in the script? So this is how the reporting will be generated in the karate skill. I think pretty much I covered the demo part. So maybe I'll hand it over to Vishwaja to continue.
Yeah, thanks, Manoj. So these are some keywords. In demo, we saw some basic keywords, but if you want to explore more, folks, then you can refer these keywords. Next. So these are some key features. Supports karate framework as we seen in demo, automation testing using REST, SOAP and graph given and parallel execution. Apart from this, karate supports web UI automation, data driven testing, performance testing, mock APIs and contract testing. Next. So let's see the comparison between Karate, Rest Assure, and Cucumber. In Karate, we are using feature file without any step definition. But in Rest Assure and Cucumber, we are using separate Java logic to write API test. In Karate, only less code we are using because we are using gherkin keywords. And in Rest Assure and Cucumber, line of code is more. Karate is less complex than Rest Assure and Cucumber. Karate supports the parallel execution, but the Cucumber and Rest Assure does not support the parallel execution. Next. So these are some advantages of the karate. If any person have the little knowledge about the coding, they can start with the karate. And it is a very powerful JSON validation. One can do the coding in JavaScript as well as in Java also. Karate features a multiple threading parallel execution, and it has detailed logs and reports also. Next. So to know more detail about the karate, folks, you can refer this link, and we also put our code in Git. Maybe folks, you can check out later.
So in this demo, so we have just covered only one piece of karate. So wherein we have targeted only the API test automation. So still using this framework, you can explore the other scenarios as well. This one, performance testing using Gatling also possible. And web UI automation also it's supported. Even you can explore on mocking an API and contract testing as well. So these are the other added feature which is available in karate. So still we are also exploring on this part. So using this framework, in a API test, so you can write it in a simple plain text. So similar to the karate BDT UI automation tool. In the same way, you can write it. So which will be easy for a non-technical person. Even for a API test, you'll be able to understand if you structure your test in this way. So and also you can extend this framework for GraphQL and SOAP as well. So those are the few things which karate benefited us. So I think that's all from our end, folks. So maybe we would like to hear if there is any questions from anyone.
Manoj, we have some questions in the chat.
Yeah. Yes, Sriram, we can implement POJOs as well. So that is also possible. So whatever Java logics which we are doing it, so we can do it in karate as well. And also it's have a flexibility to integrate JavaScript as well. So how we do in Rest Assured also in karate also we can do that.
Yeah, Manoj, Tushar having one question.
Yeah.
Yeah,
So Manoj, couple of questions here. The first thing is when I looked at the feature file, uh, it doesn't seems more like, kind of readable in readable format, just like we have a Gherkin syntax in Cucumber, which is easily understandable to the non-tech people, including the BAs and project managements. So, is there any way, like, where we can write the feature file in a way which is more understandable and more clear to the non-tech people, because we know that we don't have step definitions over here. So not having a step definition, that means like whatever logic you have to write it, you have to write it in the form of the keywords which are specific for karate. So I mean, actually, my personal view is like, by looking at this feature file, it makes very difficult for the non-tech people to understand that what exactly we are trying to validate in this. So do you think like we have any kind of plugins or anything which can make the feature file more easily understandable or readable?
Yes, Tushar, that is also possible. So we didn't explore on that part, but you can make the feature file as readable ones. So in the plain English text, so a non-technical person can understand. So that is possible in the product. So
Okay.
you can refer the links whatever we mentioned in the slide. So there they are mentioned. So you have to do the implementation for that.
Okay. Yeah. And second thing is like, the complex coding which we have, the complex logics which we have to write into, like, into our feature files. So for that, do we have any kind of keyword? Because if I see the complex one, if you can see line number 36 that says eval, where we are writing the for loop which contains all the logic. So this is a very basic for loop which we can
Yeah.
add. But let's say we have to add some complex coding or complex logic we have to implement into finding some particular attribute or particular node from a response and finding with validating some specific attribute value. So I mean, how we can do that? I mean,
You can use the same logic to share how you will be doing in Java REST assured. The same way you can do it here as well. So in order to have this feature file more simple, you can add that logic in a separate class file, and then
okay,
you can
okay,
call that function here.
okay, okay, okay,
So
okay.
that code reusability
Code
also is
reusability
possible.
is there. Okay.
It's possible. So I shown in a demo as well. So this is a demo for making use of a token authentication method. So in my response,
Mhm.
so this is one scenario. So if you want to do some kind of a Java validation in your response, so you can create some separate test scenario in another file and you can call it.
So is it like we have to create a separate class or we have to create a separate feature file? Because
Yeah,
here
both
both is possible,
future
right?
file also both is
Okay,
possible. You can
okay,
also create separate class and future files.
okay. Yeah,
Um,
thank you.
yeah.
Yeah,
Manoj, we have other question in the chat from
yeah,
Deep. Yeah.
sure. Custom keywords. The support for custom keyword is not available right now. So we can write our code logic. So, but not the custom keywords is not available. The next one, can we implement continuous integration with Bamboo added with remote and grids? Yes, integration with CI/CD also possible. So you can make this test run using a command line argument. So and then you can execute this over CI/CD pipeline on Jenkins or any other platform Bamboo. Anything else solution?
Do you have any question, audience?
Any questions or any doubts in my clarification what I mentioned? So if there is no further questions, thanks people for joining and spending time with us. So maybe I'll hand it over to Subha to start with the.
Thank
Yeah.
you.
Yeah, thank you, Manoj and Vishwaja. That was a great session. So I hope we all get to know some insights on the Karate framework for the API automation. And thanks for clarifying the questions as well. So the next will be the polling. So as we mentioned earlier, so we have few quiz for you. So you will get it in the chat. So please take some 2 minutes of time to complete that. Yeah.
Yeah, now poll is live, and if you are not able to see, please let us know.
So I hope 50% of the participants are already entered the poll. We have other 1 minute left. So we have other 50 seconds. So I see only 65% of the people have participated. So please do participate. So we have other 13 seconds. We have other 10 seconds. So I see only 70% are completed. Okay, the poll has ended. So thanks for participating. And yeah, it's time to move on to the next topic. So the next will be our test strategy for chatbot. So this will be presented by Monika Sharma. So to tell about Monika, so she's a quality analyst in ThoughtWorks for 3+ years. She has an expertise knowledge in creating the testing strategies for multiple projects. And she also has a good handful of experience in both functional and non-functional testing. So yeah, over to you, Monika.
Yeah, thank you so much. I'll start sharing my screen. I hope my screen is visible and my voice is audible.
Yeah, Monika.
Okay, so hello everyone. Today I'm going to talk about test strategy for chatbot. Now, before jumping to how we are going to build the test strategy and what all different types of testing we are going to consider, first we have to understand that what are chatbot, so that everyone is on the same page. Just a second. Yeah. So chatbot are the application to create an online conversation that is via text or text to speech. So in the real life, like the apps, the different kind of apps we use, have you ever interacted with any chatbot before? You can, so in order to make this session interactive, I am going to ask few questions, and you can answer those questions in the Zoom chat. Okay, so yeah, I would like to know like which all applications you have used in which you have interacted with the chatbots before. For example, in this example, I have interacted with Swiggy, and there I am asking the most common question, right? Where is my order? Or like no delivery executive has been assigned to my order, something like that. And then in return, the chatbot replies to me that, okay, this is at this place, what is the ETA, how much time will it take, something like that. Okay, so uh, it is it is not a manual process, it is like automated process from chatbot. So now let's say we are going to build a chatbot. Now, before testing, in the development step, what all are the best practices which we can consider? Different categories. So first one is the personality. Personality includes, does chatbot have a clear voice or tone that fits in with the user? Basically, this is via text to speech, specifically for text to speech kind of chatbot. Next is onboarding. Are the users understanding what chatbot is about? Understanding, which is requests, small talks, idioms, emojis. Is chatbot able to understand those emojis? Answering, are the answers which chatbot is giving are relevant to the users? It should not be like out of the blue. Next one is the navigation. Do you feel lost while speaking to the chatbot? Another one is error management. How good is chatbot dealing with all the errors going to happen? And the last one is the intelligence. Like, is chatbot able to remember few things or not? Now we have seen the UI, just the UI, but under the hood, what is going on? Like what all applications are there? What all different components are there? What is its architecture? Okay. So for the ease of understanding, I have taken an example of very simplified chatbot. Okay. So this chatbot can be a mobile application or a web app. Let's say when a user messages in chatbot, it sends a request to the dialog flow. And then after that, basically with the correct parameters, then dialog flow receives the request and send it to the GCP, Google Cloud Platform. Then GCP receives the post request from the dialog flow, and it basically reverts with the parameter to return more, customized answer. After that, dialog flow basically then contacts the webhook if the intents uses some fulfillment or some of the intents to respond to the request and then responds back. It handles a natural language processing kind of thing to basically choose the correct response, and finally it responds back to the chatbot again. Okay, so this is very basic and the simplified example I have chosen. And next one is setting up quality gates. So for now we have seen what are chatbot, what are the basically the best practices which we can include while the development of chatbots. Now we are going to see how we are going to set up, or which all things to consider basically to set up the quality gates. Okay, first one is to identify the goals of testing. Okay, basically means that we are going to validate input and output as per the previous flow diagram which I have shown, the request and response. We are going to validate it, validate context, validating intents, fallback intents, validate the bot response on the UI, and then validate the usability. So there, these context, validating intents, and fallback intents, these three terminologies are very specific to the chatbot. So first of all, the context, it basically means a unique identifier which is given to a conversation with the user, as well as a counter that is incremented with each turn. So if we don't preserve a context, each round of conversation or input, it will appear as a start of conversation. It won't hold on. Okay. Next one is intent. It basically refer to the goal the customer has in mind while typing in. Fallback intents, it basically if chatbot doesn't able to understand then what is the default response chatbot is giving. Okay. So for now you have understood what goals of testing to consider. Okay, and what is its flow diagram. I would like to know from you that what are the different types of testing we can consider. Okay, you just mention in the Zoom chat. Yeah, it will be a quick one and then I'll move to the next one. We have identified the goal of testing. Next one is mapping the goals with the testing level or the different testing types. So for example, here, the first one, validate input, output, and validating context. We can validate it with the help of API test. And then validating the bot response on the UI and validating the usability as well can be done with the UI test, whether whether it's on web app or whether it's on mobile app, we can validate with the our specific UI test. And then at the end, we can put it in our CI/CD to run these tests as and when required. Next step is consider the cross-functional requirements also. Okay, so usually we get so involved that okay, UI tests are running, API tests are running, everything is done. It's not done yet. The next cross-functional requirements to consider is usability testing, performance testing, and security testing. So let's say I have typed where is my order. Okay, so I can also type something like order where, or in some other language like usually in Hindi or in any of the language, how my chatbot is responding, whether it's supported or not. Okay. Next is performance test. How many users are using or asking their questions in the chatbot at that very point of time? Okay, that is also part of performance test. Then the security test, whether our conversation is secured or whether that whole chatbot ecosystem is secured or not. So it will be tested via security testing or vulnerability testing. Okay. Next is picture the overall strategy. It basically means that you have step one, which is finding, setting the objectives of testing. Then step two, defining what to test at every level. Third step is cross functional. And after that, you have to see how you are going to, picturize it in a high level overview. And then after picturizing all these steps, like as an overall strategy, we should not forget that the strategy which we have created, like in the beginning or while the inception time or at the very early stage, it's not it. I mean, after that it should evolve as and when, like let's say a specific component get involved. For example, right now I have talked about a very simplified flow of chatbot, but let's say a chatbot has AIML and it's built on the top of that. It has some models to decide the response. Then ideally the strategy is going to evolve over the period of time, because in at the inception period you'll get a gist of idea like which all components will be there in the flow, in the whole ecosystem, let's say of the kind of architecture which we are going to build in. Okay, but so yeah, so slowly we have to evolve it over a period of time. And the last step is don't assume while preparing the test strategy. Always raise question, as in that what about the local app, the app which is on mobile phone, or what will be the response if bot is down, what how the garbage text can be handled, something like that. Okay, now we have discussed about, okay, what our test strategy looks like, but what about the tech stack? As in, we have seen UI test can be added, API test can be added, performance test, usability test. There are a lot of tests we have seen, but what about the tech stack? So let's say we have a base development code written in TypeScript. Okay, so our first instinct says that let's not go for something which is very trending. Let's say we can write our test in API test, sorry, we can write our API test in rest assured, and let's say UI test in Selenium for basically web app testing, because Swiggy app or Swiggy, we can use Swiggy web in the website also, right, in the web app also. So, and plus for mobile, in order to test those the chatbot related thing in mobile via APM. Okay, so if we go in a traditional way, we can use whole this slot of tech stack. So what is the advantage of this is that let's say if any new QA gets onboard into a project, okay, and then it will be easier for him to understand that, okay, how it is written, which all, for example, Selenium. I hope mostly every one of us knows about it, like how to use it, how to write test, basically. Let's say if our development code is in TypeScript and we go ahead and decide the TypeScript or let TypeScript as a base language for writing our API test also. Let's say super test, or let's say if not TypeScript, then something very familiar JavaScript. Then we can write our test in Test Cafe also. There are different options, but depends on the requirement also. For example, if I go ahead with the super test and the Test Cafe, if I hand in, maybe I have built a framework, then later on I can uh, add this as a acceptance criteria, that let's say if developers have created these features, then at the end they should add a test, they should add some test in the API test suite as well as in the UI test suite. Okay, so it will be easier for them, to write the test in JavaScript than, let's say writing a test in Java for rest assured, then again Selenium. So we have to consider these kind of parameters also in mind while preparing for, our tech stack, like what can be our base languages of test can be, or what kind of libraries we are going to use for API testing, UI testing, let's say performance testing as well. So we have to run a specific POC as per, what a client ecosystem have and what all they supports within, because sometimes, when we do a POC, we think that okay, this will work in our local, this is working in our local, but when we put all these tests in their pipeline, the test started failing because some of their features of their pipeline doesn't support, okay, those set of libraries. So we have to consider our POC as completed only when CI CD is our test is running in CI CD properly. Okay. So yeah, I mean that is a quick round of session, and yeah, that's it for now, and we can open the forum for Q&A. Okay, so in order to, as a quick recap, I would like to reiterate everything what we have discussed in the last 15 minutes. First one is what chatbot is, how it looks like, and next is what are the different testing levels we can consider by thinking about overall 360 degrees of testing from the QA perspective. And we have just talked a brief about like what are the steps involved. For example, step 1, finding the goals of testing, and then map the goals with the testing type, consider the cross functional requirements as well, then noting down your questions as well. Okay, so considering those, and after that, what can be the tech stack, and just not sticking to the traditional ones. And yeah, so this is a holistic picture of what we have discussed till now. Yeah, Shweta.
Yeah, Monica. So I have one question, like how are we supposed to check if the model, like whether the model is improving after some iterations or not? Like, would that be a part of like test strategy also?
Can you give an example?
Like suppose we build a model, okay, the chatbot is there, and we are like in the first iteration of like testing whether this is working fine or not. So after some rounds of testing, so is there a way to get to know like the performance has also increased? Like can we say as a QA, like we have tested the chatbot and it is up to this benchmark, like like
Okay.
generally, yeah.
Yeah. So yeah, sorry to interrupt. Okay, so this, I mean, it's not specific to the chatbot, it is specific to any application which we are testing. Okay, first of all, always store the report, as in that, for example, we are running the performance test in the first week. We ran the test, we have seen the throughput, we have seen everything, we have noted down like how much time it is taking, let's say. So we have a report for one specific milestone. You will not get to know that how it is performing, that in that very point of time. It just, you can always get a rough idea that okay, in this service it is taking a lot of time, or in this service it's pretty fast, those kind of thing. Okay, but in the second run, when you compare with the previous run, after let's say doing some optimization in the code, that time you'll be able to understand that okay, the performance has improved or not, or whether it has degraded. Okay, sometimes it depends on the development code which we have written, but sometimes it is also dependent on the third party application as well, in case if that client ecosystem have.
Okay, okay. So that covers like the performance past, like how fast it is, how quickly it gives the response to the user. But what about the accuracy part? Like whether the response that the user is receiving, on the other hand, whether that response is proper or not.
Yeah. So in that case, we have two objectives. We have two objectives for that. First one is validating the request and response. In order to test that, we usually consider the API test as the primary means of finding like what is the accurate response chatbot is giving. Okay. So in the first level of testing, we give a specific set of input. Okay. And then we expect certain set of output. Okay. But in usability, we give a more larger or more wider set of inputs from a different perspectives, from different let's say the kind from different categories of customer perspective. Okay. And that these two kind of testing depicts the accuracy of chatbot's response.
Okay, yeah, thank you.
Does this answer your question?
Yeah, Monica, it's fine.
Okay. Yeah. Yeah, Tushar.
Yeah. Monica, one question like, how does this, testing a specific chatbot, how it is like, different from testing maybe a conventional product, like, let's say, for example, like you have a Amazon and, you want to check where is your order, you want to track the packages or something. Having
Mm-hmm.
that kind of module or product into your mind and comparing that with the chatbot. So, what kind of difference we can kind of observe, like when we are testing both products as well as the chatbots, what difference do you find in that?
Yeah. In order to answer your question, it actually depends on the use case which client have. Okay. So sometimes when they come up with the use case where they have another ecosystem, chatbot is just a subset. Okay. In that case, we tend to cover, the whole ecosystem, like by adding the UI test or API test, all these will remain the same. Okay. But let's say if they have a use case where only chatbot is involved. Okay. So that time we consider from a testing from the from the testing goal of just testing the chatbot. So it actually depends on the client's use case, which I feel. But in order to answer your question, chatbot testing is just a subset of overall ecosystem testing.
Yeah, I mean, that's what my understanding is, like, that chatbot independently we cannot test it until and unless the whole ecosystem or the whole kind of application or the product is uh, tested. Because
Yes.
if we say, like, where is my order, if you just ask chatbot like where is your order, that again depends on the backend services which are also triggering when you are working on the product also.
Yeah. And apart from that, we are thinking from a very overall picture. Okay. But let's say there is one specific assignment on which I have worked within ThoughtWorks is where it just related to chatbot. So in that case, nothing, for example, a client has a UI or a website or something like that. That was not under our control. That was not under, any of the our parent companies or the companies in which we are working in. It's not in our control. It's with the third party. In that case, I think, yeah, it will fit in. But when it comes to overall picture, it's just a subset of those ecosystem testing superset.
Okay. Monica, one last question. Sorry to taking your time. Just last question. When do you think, like, this implementation of a chatbot service lies in the overall life cycle of the product? So when we say, like, do you think that, this chatbot implementation will be more useful when the whole product is stable enough? or we can think about having a kind of chatbot implementation right from the designing of the product aspect?
Okay, so I have worked with both kind of models where we have implemented from beginning and where we have implemented, after us, maybe at the very end or maybe something in between. Okay, so the very good feedback we have received when we have when we have started implementing in a beginning, like in maybe max to max first or the second iteration. Okay, but when we have delayed it little late, then we got burden, and then we were in a hurry of just putting the test. Okay, rather than thinking that how the optimization would look like, and we didn't got basically time to look into the development code as well. So when you do it in the beginning, you have all the control over the development code as well. You have all the time to see like how the dev code is written, and then you can suggest that okay, this is how it should be. Okay, so it's all about control. And if you delay it, the more you delay, it will be in a rush, and then there are chances that you'll be having a little time to work on just a priority thing, and you will tend to miss out a certain which are important also.
Okay.
Yeah.
Yeah.
So
Thank you.
due to interest of time, we'll take one last question from Sridhar. Yeah, go ahead, Sridhar. Yeah, post that if you have any questions, please post your questions in the chat. Your questions will be answered via chat. Yeah, go ahead, Sridhar. Sridhar?
You can unmute yourself.
I'm audible right now?
Yes, you are audible.
Hello?
Yeah, you are audible.
Okay, thank you. Sorry
Yeah.
for that. Sorry for that, yeah. So how do we check that stability of the chatbot? For example, whenever a new development is deployed in web application, or maybe some updates coming in mobile application. So after that update, or maybe an upgrade of the application, so how do we check the stability? Because I've encountered an issue in my current organization with the chatbot. So sometimes I've asked the question about whether I opened a ticket, raised a ticket. So it took around 5 minutes, and then it shows no answers for that. So that's what are my questions, like how do we check the stability of the chatbot after an update?
Okay, so there are okay, so the things which I've talked about till now are just a holistic things. Okay, then at the ground level, there is something called as regression test. When it's not about just adding the test, then so let's say we have added our API test. So API test at the integration level are considered as the fastest one to run, and they give a very fast feedback and immediate feedback basically. So we can add those tests as an integration level test, and then we can add those tests as a part of regression test suite. So whenever, let's say, any update is there, we can run our regression test suite and get the feedback like which all features are running, and something like that.
Yeah, okay.
Yeah, so yeah, usually when we talk about test strategy, we talk about different types of testing. But yes, I think this is the good point to add at the ground level, which we should also think about. Like, it's not just about adding the test or running the test. It's about, like, in case if there is a change, we are going to add it as a part of regression test suite, and this is how our core testing concept will fit into this kind of picture. Yeah, so I think that there are not many questions, and yeah, that's it. Thank you everyone for joining this call. It's kind of late already, but yes, thank you so much. I'll stop sharing.
Yeah, sure. Thank you, Monika. So Yeah, if you have any further questions, please post your questions in the chat and your questions will be answered surely. Yeah, and so thank you, Monika, for sharing hints and various steps to prepare test strategy for the chatbot. It will be really helpful if we want to develop test strategy for any of the chatbots. So once again, thanks for that. And we have some short quiz for this topic as well. So yeah, participants, please feel free to take that questions. Yeah, we have 30 seconds. Yeah, I think all is enabled now. You are able to see the questions. Yeah, we have 15 more minutes. Sorry, 15 more seconds. Yeah, 5 more seconds. Yes, we are done. We can end the poll now. Yeah. Thanks everyone for participating for this poll. And we'll move on to the final topic. The final topic is test cloud native applications, and which will be given by Lipika. So Lipika is a QA and she's having 7+ years of experience, and she's passionate towards delivering quality products, and she's skilled in manual and automation testing, and she keeps herself updated with the latest testing trends. Yeah, over to you, Lipika.
Thank you, Punita. Okay, I will quickly share my screen and let me know if the screen is visible. Okay.
Yeah, it's visible.
Yeah, thanks, Monika, for the introduction. And hello, everyone, and a very good evening. Hope you've got really good insights from the last 2 talks. And I think it's pretty late also. So I will try to cover nicely. Hope you would get some of it. And in next 45 minutes, we will try to see what cloud native is and how in this today's world, we as QAs will have to keep ourselves, updated with cloud native applications and how can we test as well. And we will also have a small demo where we will spin up a Kubernetes resource using infrastructure as code using the tool Terraform. So yeah, and we'll see how it will be a small demo to get started with, and then further we can explore it further as well. Yeah. So if I have to talk about what cloud native is, right? So cloud native basically is an approach to building and running the applications which uses cloud computing delivery model, and it helps in running the scalable applications. It is also the future of the app development, and we have already seen that most of our applications are now already moving to the cloud native, right? And being that cloud native is actively getting adopted, we QAs should also start working towards this, right? So before we get started on this topic, yeah, I think Punita has already introduced myself. Yeah, this is a quick introduction about me. I'm also a security enthusiast and I'm also a blogger where I have my Medium blogger. So if even this talk is somewhere present at the Medium blog, so if you want to reach out or have anything, you can reach out there, right? Yeah. So when we talk about monolith architecture and cloud native, right? So earlier we used to have this monolith architecture, and now we are moving towards the cloud native. So now, what is monolith, right? So monolith is something like a traditional model of app development where all the components are tightly coupled. Like we can see here, right? UI, business logic, and data access layer are all tightly coupled here. And even for a small functionality change, we need to redeploy the entire application, which would anyways take a lot of time for the deployment process. And hence it becomes a tedious job, not only for the ones who's deploying and developing the code, but also for the QAs to perform the regression testing on the entire application, right? And mostly because of this time consuming process, deployment also happens once in 6 months, right? And at the same time, cloud native is literally the opposite of what we call as monolith architecture, where every component, which are also called as containers or microservice,
are loosely coupled and is independent to each other. So these containers are then connected via the cloud. And since every component here is independent, it becomes very easier to maintain. And it also, we can also say that it becomes a collective or a shared responsibility also to manage, right? So unlike Monolith, for cloud native, for small functionality change, we can only make the changes to one of the containers which requires it and deploy only that component, right? And at the same time, QAs would also need to focus on that specific component, right? So here we generally try to release early and often and get the feedbacks earlier. One more major advantage of cloud native is its ability to scale and freedom to choose the tech stack. Whenever during the process we feel that the tech stack is not proper for a container, it becomes easier to migrate that specific component, right? So that these are some of the advantages of cloud native. And now that we know what is the difference between monolith and cloud native, let's see how it is different in the testing side, right, for each of this architecture. So testing in monolith architecture, like we all know, is something that we have to do after a feature or a functionality is developed and before it gets deployed to production, right? Similarly, in the cloud native apps, since everything is hosted in cloud, we QAs need to be alert all the time. And it is like a continuous process. We have to test this at every stage of software development lifecycle, even for a small bug fix or functionality change, or after every build that the developers can push, the changes goes to the cloud, right? And we can test them immediately. Not only in the dev environment, we also need to ensure that it is done, during the entire deployment process and even after the product is released. So essentially, we QAs are always testing in this cloud native world, right? So, and now we know that if cloud native is there, we will not run out of the work and our job is literally secured. So yes, we can also say that deployment and testing in this also happens at a common place, which is again a cloud. And in fact, when we talk so much about cloud, there was actually also a meme that was very famous, right? There is actually no cloud, it's just someone else's computer. It's a common server that is used after all, right? And so that's how a very famous meme that came in. And if we say that cloud native architecture was built in just an overnight, no, it took some time. It was not an one-day discovery that happened. It had its own journey. So it has evolved over the ages from virtual machines, like we can see how it started with non-virtualized hardware, and then slowly it moved to IES, then open source tools, containers, and then it came to the cloud native, right? The major turning point that happened in the cloud native architecture was when the Kubernetes was introduced, right? Kubernetes, or KTS, we call it as, it was actually created by the Google and was later taken over by the Cloud Native Computing Foundation as a fully open source project in 2015, right? So what is Kubernetes? Kubernetes is, like I already mentioned, it is an open source. It is a container orchestration platform, which is responsible for effectively managing the application's deployments. And now, like CNCF has taken over, so it is responsible to manage the Kubernetes project, right? And this evolution, there's a lot of demand for expertise in Kubernetes as well. And in fact, most of the developers or DevOps and even the QAs, we need to understand what exactly and how, in fact, the Kubernetes architecture, or what are the terms that are generally used, right? Cloud native, there are multiple, again, I want to reiterate, there are many other tools also. It's just that I'm taking Kubernetes as a base so that we at least understand the base foundation of it, which would eventually get applied to any other tools or platforms that we further take it on, right? So yeah. So just to quickly understand on some of the terms that we use in the Kubernetes world. There is a pod, which is the smallest set of the containers deployed to a single node. Kubelet, it's a container agent. etcd, where we store, right? Similarly, kubeproxy, cluster, node, and all, right? So a container, when we talk about the container also, it is a standard unit of the software that packages up the code and all its dependencies so that the application runs quickly and reliably and independently. So, I mean, it's okay if we don't understand this concept immediately now. I hope most of us understand, but in case if we don't, then we can always go back and check, right, on the what is a container is. Just one liner, it is the smallest unit of a package software, right? And node, similarly, node is responsible to perform the task assigned by the controller. Controller is someone who is responsible to, like a head of the family, right? So similarly, controller does all the administrative tasks that happens. Persistent volumes stores the data, and so that it can stay it there for a longer time frame. And anyone who wants to refer to the data back can always, any container can refer to this persistent volume. Service, when we talk about the service, is actually a method. We will see when we spin up the pod service and deployment, and we can host the application in the network, right? Deployment ensures to automatically spin up the pod in case of any failure. So in case if there is any, if the application goes down or any of the pods or any of the containers goes down, then deployment would actually, it will keep monitoring and seeing that if everything is working fine and all, right? So now that these are the few terms that are widely used, and you would hear this very often while working with the Kubernetes also. And yeah, so you can refer to this one-liners also. Now let's understand the various components of the Kubernetes, right? So majorly there are three components of the Kubernetes: master node, worker node, and etcd, which we have already seen. It's a key value store, right? So this is how the Kubernetes architecture diagram looks like, where master node is the first entry point where all the task begins, and it is responsible. So it also contains the controller, manager, scheduler, etcd, and everything. It is responsible to controlling and managing the worker nodes as well. And these are the worker nodes, right? Worker nodes is any physical or virtual machine which runs these applications via pods and is controlled by the master node. So if you see, these worker nodes contains various pods here, right? So in this, and every worker node will also have one kubelet and one kubeproxy. Kubeproxies are responsible to interact with the users, while kubelet is interacting with the API servers, right? And in cloud native application, you will happen to see these kinds of multiple worker nodes, right? And yeah, now that we have understood the architecture at a higher level, let's see. Well, in fact, if we think that Kubernetes is just a container orchestration tool, then no, it's like a Swiss Army knife and it has a lot of things that it can perform, right? There are many features that this Kubernetes can perform, where we have disaster recovery. It can happen, automated rollouts happens. We can deploy automatically, as we have seen in the earlier examples, right? So now what Kubernetes and software testing has to do, right? Fair, we understand that Kubernetes is helped to spin up the clusters. It helps in the deployment. But where does it fall in the software testing world, right? Basically, Kubernetes has literally changed the way we think about running the containers at scale. And so far, operation teams and developers, they have been working on this essentially for the resilient delivery of the applications in the cloud. But what has changed is the execution model of different types of testing. And as each type of testing, be it unit testing or integration or in fact a system testing, it requires different setups and configuration, right? And it takes time and effort to automate these stages. And with different configurations, we cannot keep spinning up multiple, or we cannot have multiple environments, get hold of it. It definitely takes up a lot of cost, right? However, with Kubernetes, we can have a platform that scales based on our requirement. Whenever we need it, we have this environment, and when we don't need it, we just destroy it, right? So we can leverage this to incorporate more advanced testing scenarios, possibly like a chaos engineering or A/B testing, or in fact, even in real production sites also, as well, right? So as to reduce the risk and make our system more resilient to failures. It also helps in the debugging process easier with availability of logs to every member in the team. So if every member, since this is already there in the cloud, and if every member of the team can access the test environment hosted in the cloud, this would definitely ensure the faster feedback and smooth communication within the team. We did not copy paste. If we say, sometimes it happens, right? We paste half the logs and then send it to developers. They were like, this is just half the logs. What else? What is previous and what after that, right? So we can simply share it because it's always hosted in the cloud. It becomes easier for, the communication, and whatever the required information is needed by the team, it can easily be flown across. And while we spin up this environments whenever we need, this would definitely reduce the cost, and we need not worry about what kind of configuration. We can also have like a production kind of environment for some time, perform our testing, and then destroy it, right? So like we said, unlike monolith architecture, we are now moving towards the shift left testing model, ensuring that we test right from the beginning, right? And now it becomes very crucial that we also have some test plan strategy around this. Given that we have started right from the beginning, that becomes, it is more or the less same. It's just that we have to relate how earlier we used to test our application versus keeping the architecture of these cloud native applications in mind, and then design our test strategies, right? Before I move on to demo, any questions? All right, I'll take that as no. And let's see, we'll have a small demo on and how we can spin up this Kubernetes resource. I am using Terraform infrastructure as code to spin up the Kubernetes resource. I could have done only using Kubernetes also, but I wanted to do it all at once in the interest of time. So, and in fact, in our projects also, this becomes easier to maintain, right? Because Terraform essentially is an open source infrastructure tool that enables to safely and predictably create, change, and improve the infrastructure. So we have this Terraform also provides a Kubernetes provider. It has this, it has this support where this provider, Kubernetes provider, helps to interact with the resources which are supported by the Kubernetes, right? So what we will do is, in this demo, we'll create a scalable Nginx deployment with 2 replicas where we'll have 2 pods. Why I'm saying 2 replicas? In case one goes down, the other is there. And we'll also expose Nginx to the front end using a service type. And then we'll delete the pod and see if the disaster recovery happens or not. Like when I say disaster recovery, whether it is able to scale up automatically or not. And then we will destroy the resource because we are done with the testing. So we'll sort of destroy it as well, right? Yeah. So before that, like I have already started my Minikubes here. And Minikube, I'm using it for my local testing of the Kubernetes. You can also try it out. It's not a paid version. So if you want to try it out locally in your machine, feel free to use Minikube. I've already started Minikube and it is running in, I can show you. So it is running in this IP, and the port that I have used is this one. So right now you can see Nginx is not up and running, and the port is here, which I'm using. 30201 is my node port that I'm using, right? So now so this is my Terraform code where I have added, what all I would need. So Kubernetes namespace with the name Nginx, similarly deployment, and then I'll have 2 replicas. So this is the config file that I have, right? And similarly, this is a service that we just talked. And there is some network policy which has egress and ingress rules, what network to be allowed and what not to be allowed to come in and go out of the network. So that is there. It's a simple Terraform code that is that I've written here, right? So now what I'll do is I'll just apply this Terraform. Okay, yeah, before I apply this, I will also see if anything is running for my Nginx or not. -n is for namespace, right? Yeah, so nothing is running. So now Terraform apply. I will approve this. Okay, now we see it's creating and we see this immediately the pods have come up, right? And it has also created a replica set, and then we also have a deployment, right? And now it's running. It just took few seconds to bring this environment up, right? And now if we go back here and see what happened, oh wow, I have my application ready. Now I can perform any testing that I want to do, and once I'm done, I can get over. So what all that we did is, so we have created a scalable this one, and I have a 2 replicas, 1 pod here, both the pods, right? And then, yeah, now what we'll do is we'll delete a pod and see if the other pods comes up automatically or not, right? So I will delete. Okay, I have a command handy. I will make use of that. I will just replace my the name of the pod from here, and then okay, now let's. Okay, now you see it got terminated and immediately it has, 1 was ready and now 2 is ready, right? So immediately I was able to recover the failed pod and it was very quick, right? So this is one of the feature that Kubernetes provides, which is a disaster recovery. In fact, say for example, 2 is not enough, right? In some of the applications where a lot of traffic is required, we need more scalable applications, right? So what we can do is, without doing much of a deployment, I would just change my number of replicas here to say 3. I'll save this, and what I'll just have to do is apply again. I'll approve this. And now it is actually creating 1 more container, right? See, 2 of 3 is ready. And now it's creating 1 more. Voila. So now I have 3 pods which is running, and if there is any traffic, it can redirect to any of these based on the configuration it requires, right? So yeah, so what we have done, yeah, so we have deleted a pod and verified that it recovers. We have also increased scaled our applications for this thing, and now if we don't want these, but I still want it, then what possibly we can also make this as 0, right? And then just say apply. Now we'll see that the pods have started terminating. Though the pods have started terminating, my service and deployment is still there, right? So in this case, the environment is not destroyed, but it has deleted the pods, right? So to deploy possibly, and if you want it back, we can just say, again, increase the replica set to this one and say, just Terraform apply. And immediately it comes up. Now, if you want to destroy the environment completely, given that I'm done with whatever testing that I had to do, and now I don't want it, all I need to do is Terraform destroy. Okay. I will approve this. And now we'll see, okay, now everything is getting terminated and there is no resources, right? And it's destroying. Fine, it got destroyed. And now we can go back and see here if my, okay, now my Nginx is not there. Right? Yeah, so yeah, this was a quick demo on how we can scale up the application, how we can test if things are not working fine, right? By destroying the pods, by bringing down the applications. If we need to test it in a scalable and applications, how we can make use of this Kubernetes and then bring our own cluster. I'm doing it by local. We can also get this in our Jenkins or CI/CD pipeline, where we can, spin up or destroy these environments that we use it. Okay. All right, I will move forward. So next, what we have is different measures in cloud native applications, right? So there are various measures in cloud native architecture like scalability, resiliencies, robust deployment, resource utilizations, which not only ensures the better development of the application, but also ensures the efficient and effective testing, right? I think few of which we have already seen, where scalability was nothing but its ability to scale the containers or pods based on the real-time requirement, like we have already seen. Maybe I think right now we also have this big billion days or running, right? So whenever we have this sudden spike of users, all we have to do is we need to ensure that these containers are automatically scaled up, right, to incur such heavy demands based on the data storage capacity or the processing power. So along with this, we also need to ensure. So one is definitely scaling up. The second thing, as a QAs, we also should have that strategy saying that in case of there is a heavy demand, scale up automatically, but in case there is no demand, then scale down as well, because we don't want to keep our pods or containers running just for fun, right? We don't want so many things in case there are no such use. So some of the basic requirements or scenarios that as QAs or whenever we plan our test strategies, right, around these applications, few things that I think even in the previous talk where Monika was mentioning, right, raise your questions, right? So similarly here also we should think about how can we ask the questions, right? So in such scenario, what can we think about? So what happens if the instances are no longer required, right? How is the service scaled? And how would the traffic get routed if when the nodes are overloaded? If there are too many traffic going in the same pods, is there a proper load balancing that is happening? Whether it's going equally to every container or is it going to the single pod only? And in such auto scaling testing, we also need to watch out for any kind of memory leak. If all the threads are getting closed along with proper login and CPU utilizations, right? So when we have to test around these aspects, we should ensure that we understand, like I already mentioned, understand the architecture of the framework that we use, and then come up with this test strategy that we have to bring out with and relating it to the real life use cases. Okay. Similarly, the second measure we have is resiliency. And this is the ability on how can we recover the failed cluster without losing the state. Like we have already seen, right? The pod goes down, it auto scales or not. Just think of an example, maybe an e-commerce only. We are in the middle of the payment and suddenly the app crashes. Is it able to recover itself in that scenario? If has my data been lost, right? So in these cases, we have to ensure that the proper load balancing is happening. So if one cluster or one pod is failing, whether it is immediately redirected to the disaster recovery cluster, right? Ensuring that no impact is happening on the user's experience in terms of the functionality on the performance. Neither I should compromise on my functionality or the performance, right? So this also helps in maintaining the impact of the cost associated with the business. So similarly, again, if it is getting failed, right, then is the system degrading gracefully or is it lying halfway somewhere around, right? Can we still respond to users' requests if legacy systems are unavailable? So essentially, Kubernetes offers this feature of rolling restarts and ensures the automatic spin up of disaster recovery clusters happens. So we have to think in those lines as well, right? All right. Yeah. So next is the robust deployment. So when we plan out on the automation efforts for cloud native apps, we should also focus on the valuable areas that and not just focusing on automating everything. I think we keep on saying that automate everything is not a smarter choice, right? Since time is limited, it definitely won't be possible or even add value to automate everything, right? So we should always focus on the valuable areas and features and ensure that the test packs are robust, which is definitely a key point here, right? We should have a robust test packs, and the focus should not be on the large, unmaintainable or unreliable regression packs, which adds no value, but definitely a smarter test suites to run during the deployment, which can simultaneously validate a deployment and also perform a selected test set of functional tasks, right? So this type of automation regression will definitely add the value, and accordingly it can be expanded or reduced whenever the product matures, right? So please ensure that, because this with cloud native, the applications will definitely scale up higher. So having that test plan strategy earlier in the life cycle, right, and thinking in those lines right from the beginning is definitely a smarter choice, rather than just going and jumping onto let's start automating everything. That's definitely not a recommended practice also, and we have seen a test pyramid as well, right? Yeah. So next is the resource utilization. In the traditional applications, we've always seen that operations teams would primarily be engaged in managing the infrastructure resource allocations, right? And even that happens manually, right? While in cloud native applications, resources are utilized via central orchestrating process that dynamically manages and schedules containers. Like I think in the previous demo, we have already seen how it was just with just one command, it got auto created, right? We can also schedule these commands in our CI/CD pipeline and get it deployed, right? So since this is, we can also have based on certain rules, which DevOps can set up, and we can have this load balancer set right there, and accordingly it can be maintained, right? So otherwise it can also result in the lower utilization or increase in response time of the test. So proper configuration by the DevOps and to know which container to spin up when would definitely help, because it would reduce the cost associated along with the maintenance and the operations, right? So quickly moving on to many of the functional aspects don't change much, because functionality wise everything for a user, everything looks the same. And even for that matter, the functionality testing, when the QA is performed, it does not change drastically, right? While the functional testing does not change, the cloud has something very different, ways to meet its non-functional requirements, right? Especially when we start about developing this applications, right? So cloud native alongside offers a lot of testing, and at the same time helps testing apps in a better way. So let's see on how we can achieve some of these things. We have, A/B testing performance. I have not covered all of the non-functional testing that can be performed in a cloud native applications, but just at a higher level, which are the most important, right? Like for example, A/B testing, performance, security, and infrastructure. With cloud native applications, infrastructure testing is a mandatory, I would say, that because there's a lot of infrastructure in getting involved here, right? So when we talk about A/B testing, it is nothing but releasing a version of the product to a specific set of the users. I'm sure we have using the Android apps or maybe any other applications, right, where we have this beta version that gets released only to a certain set of the users, right? So as when we see this, so and when we perform this A/B testing, even we can do this, right? Then we have to ensure that we route to a subset of user on such a way that it has some certain routing rules, right? Routing rules often includes various factors such as browser versions, user agent, geolocation, or what operating system they are using, right? And after we measure the previous version and then the newer version, maybe we can set the benchmark and see what is the response coming in. Then possibly we can think of to update our production environment. So our alpha The previous version is also there and the newer version is also there. And this is actually a real-time user traffic testing, right? So this also ensures that we have zero downtime, and alongside we can test a feature with real-time production data and users, right? While everything this is happening, right, our job is not yet done. We are there everywhere, like I've already said. Even during the A/B testing, it happens. We have to be, provide that specific or select that target audience and identify what kind of users and we would want to target on, right, with a reasonable period to see that statistics match and all, right. While this is a very crucial thing, it might sound very simpler. There are several factors that can skew up these results. It could be false positive or bias sampling, right? Or even for that matter, external factors, say marketing promotions or seasonality based on that. So basically, we have to think about all these things when it comes to A/B testing. And while this is going on, careful monitoring of the logs and the traffic is actually becomes difficult, but we have to ensure that it happens. And okay, I'll just put it in a simpler word. Say, for example, if we test a product page A versus product page B, or say a checkout page C or a checkout page D, right? So in these cases, which set of users using what kind of page gives me a better results, right? So I can release two versions to a different set of users and then see my results, and then accordingly we can compare and then upgrade it to my production environment, right? Right. Yeah, security testing. This is one of my favorites when it comes to security testing. And in fact, why this has become a very much of hype also, right? Because everything is on cloud, right? And security is definitely one of the major challenges for applications that are hosted on cloud. It is very crucial to have security testing because as of today, most of the data, in fact, I would say all the applications have sensitive data in them, right? And the main objective of cloud-based testing is to stop any threat or malware from accessing, stealing, or manipulating any of our private data. So essentially, this is a mandatory step that is required for a cloud-based applications, right? One good advantage that we have in the security testing is that it can be applied to larger applications. And then with strict budget also, there are many on-prem tools and infrastructure that are available to perform the security testing. And there are certain, from the shift left testing, there are certain scanners that are available where we can scan our, infrastructure or the code that we have written well ahead in the advance to ensure that no leakage of the sensitive information happens from the code side. If I'm not wrong, there was a recent breach that happened where one of the employee had accidentally pushed a very, password or a sensitive information to the GitHub. While it was pulled back immediately, someone had actually caught it, right? So these kinds of scanners helps in identifying any kind of security threats well ahead in advance, right? So we should be very careful when it comes to the cloud-based application and security. Yeah, the last one, what we have is the infrastructure testing. Or not the last one, sorry, the third one. And after this, we'll see a small demo on how we can scan the code and all, and how can the infrastructure help. So cloud testing. So when it comes to the infrastructure testing, it is more around if my application has been deployed with the expected configurations, whether all the configuration from various things are matching or not, whether it is able to deploy the applications or the container with the required infrastructure at hand, right? In fact, this is more like a running manual and automation testing on a cloud computing environment with these kind of infrastructure, right? when I talk more about infrastructure, right, it's more like an infrastructure as a code is something that we often, I think we have already seen that there was a Terraform script that I had written, right? So it is nothing but we call it as IAC, which is infrastructure as code, and it helps in managing and provisioning computer data centers as well, rather than physically in configurations and all, right? So we have to see if things or configs are fine or not, right? So to quickly see how we can scan, so I will be using one of the tool, which is a TFSec. TFSec has a lot of advantages. I am making use of only one. It can also run in like, Terraform scripts and all. So it is mostly a static analysis security scanner for Terraform code. It is majorly used for Terraform code only, and it can run locally and even in our CI pipelines. It's very developer friendly, and the output that we get can easily be understood, and it has reference links as well, right? So we can make use of that. And we'll also see where if the creation of the infrastructure, I think we have already seen that especially when it comes to the infrastructure, right? Some of the major steps that if anyone is going to go ahead with the writing the infrastructure, one of the definite thing is identifying the prerequisites. What is my required infrastructure? Then writing the configuration accordingly, initializing this directory, and validating this configuration. Then it comes the creating the infrastructure. So even before we create the infrastructure, there are a series of steps that one has to identify, right? And then after we create an infrastructure, we have to inspect whether the states are running up and fine or not. If there are any failures, then we do the troubleshoot. And if there are any logs or something, then we'll see what are the next steps, right? So those are the things. So quickly, I also have TFSec installed in my this one. So if I show you, and this is very easy to install, right? The Terraform, we just need to do brew install Terraform. Similarly for TFSec, it's brew install TFSec, and you'll get the these two platforms, right? So if I will run this TFSec in the same file that we have, so we have already seen that this is my file, right? And yeah, so before I run my TFSec, I will also see if my config is correct or not. So I will just Terraform validate. I will validate the file. Yeah, so my configuration is valid, and that's when things were running. And now let's run the TFSec command here, right? So all I need to do is TFSec dot, and it would run the scanner in the current directories, right? Oops, now we see that there is a one potential problem that got detected here, and it would give me other results also. It would say, okay, so it also says what is the criticality of the bug. What is the bug? So it says network policy allows egress to the public networks. And on line number 93, okay, so in line number 93, I have given access to all the public network, right? If you want to know, right, here the links are provided, and we can actually go and see what exactly is the issue. So maybe I can quickly show you here. Right, so here it would actually tell me this is an example here, right? And this would tell me everything about what is required and all, right? In fact, this also has a link where it shows what is the bad example and a good example for this, right? So we see this public egress should not be allowed via network policy. Criticality is higher, and it has some explanation where it says insecure example. Bad example is where we give access to all the public networks, and the good example, it says I should have restricted public network, right? So I'll just copy this and we'll update our code accordingly and see what happens. So here in line number 93 it happened. So yeah, so I will just do this and I'll save this, and let's run the tfsec command again and see what happens, right? So now we can see now all the config files, and we were able to detect any kind of security vulnerabilities from the code side earlier in the life cycle. Yeah. All right, and accordingly, we can also see if the configurations, I think when we spinned up the cluster, we have already seen whether my config was correct or not, right? Whether my 2 replicas got created, whether my service got created or deployment got created, how many, how was it? Sorry, I'll just approve it. Yeah. Right. So how many pods are getting created? How many replicas? So this is what the infrastructure. There are many other things that comes, but at just a basic level, we can cover this. Okay. All right. Next we have is the performance testing with the scalability of the cloud native applications. Not only the security, but performance also becomes one of the crucial type of testing here. There is actually, when we talk about the performance testing, even here, I would say, I believe in there is a fundamental shift of approach, right? So for monolith application, we have always been, testing the URLs to do the performance testing. And at the same time, when we talk about the cloud native application hosted in clouds with various containers, not only just the URLs performance or the APIs performance we have to consider, but also at the cluster or the containers performance, right? It's more towards that we are moving from the URL side of approach to a more from a container based performance, right? Like I think we have seen here, right? Like how much time does it take to spin up a cluster, or how much time does it take to spin up a pod in case of a disaster recovery, right? So in that case, we have to see whether it is taking more or not, right? If there are any other code that is running inside, any kind of leaks that's happening, right? So all these things, if we hit to one container, like say, for example, I have a users, and then in between, if I don't have a load balancer, then if all my request is going to a same pod or not, is it properly getting balanced out here or not, right? So all these things would come under the performance testing, right? So when load balancer is between doing the performance test, we need to ensure the right balancing of the request is sent to every node based on the configurations and rules that have been set here, right? While we talk about this, one more thing that as QAs we should keep in mind is, while coming up with the test strategy, is the test data preparations, or to what data, what size is being used for the nodes or containers, and then analyzing the results accordingly, right? So I think, and this is not only for cloud native test data preparations. I think we have been doing it since long, and it has always been one of the key factors when it comes to the performance testing, right? And then same applies it here. And like I've already said, it's taking in whatever the learnings that we had from the monolith, understanding the architecture of the cloud native, and seeing how what all needs to be added or removed, or what can be enhanced to make our test strategy better, right? Yeah, and with this, I am almost towards the end of our presentations and also the talk. And with this getting, with the applications getting upgraded to cloud native, we QAs should also get upgraded, and we should keep a track on what are the new trends that are getting in. Like we have Terraform that has that. One more tool that we have is the Rancher. And in fact, there are many other, right, cloud-based platforms and tools that are available in the market. And testing has always helped us build applications that are more maintainable, debuggable, reliable, and performant, allowing us to shipping faster with more confidence, right? And as these applications becomes more complex, there are, because people out there will definitely look out for the failure modes, and it becomes even more difficult to troubleshoot and anticipate, right? So in order to efficiently detect and debug these issues, we should sorry about that, we should always review our test strategy and how can we use this traditional testing techniques to embrace the new ones and apply them going to the next cycles, right? And only then, like I always say, testing can return to be the valuable ally as it was in once delivering a high quality software. Thank you. And yeah, I'm not sure if there is any questions, but if there are, just this one. So this is my Medium link. The demos are not part of the blog that I have written. And I keep an eye on, I would soon update my blog accordingly with the demo, because the thing, it was written quite some time ago, and demo I have upgraded it to using, with Terraform and TFSec. So keep a watch on, or in case if there are for anything else also, you can reach out to me on my mail or ping me personally. I would love to catch up with you on this. Okay. Thank you all. Thank you. And thank you for having me here.
Yeah, thank you, Lipika. So that was a wonderful session. And thanks for sharing your knowledge on testing the cloud applications. Thank you for that.
Yeah, I just
And
finished on time. I was running at the end or somewhere, but I really hope that you got something out of it.
yeah, sure. Thank you, Lipika. So yeah, we came to our end of the session. So we have a final polling. So yes, so we have 1 minute and 30 seconds for that. So I hope you are able to see the polling. If not, please let us know. So we have other one more minute.
Yeah, meanwhile, if you have any feedbacks for me for the talk, right? Just requesting, I would love to hear them, maybe over here or over the chat, or maybe you can just pass it on to the VodQA team who had been organizing this. So would love to hear about that. Oh, it looks like Dinesh has shared a feedback for me. Okay, I stole the line, is it?
No problem. So we have a feedback form in the chat. So please do fill the feedback so that it will be great helpful for us for the further sessions. Yeah. And also we will share this feedback in the email as well. So you can share. And we have other 20 seconds. And also, like, if anyone willing to share your feedback now in live, you're always welcome. Yeah, you can unmute yourself and share your feedback. Okay, the poll got end. Yeah, so thank you people. Thank you for joining, and we also thank the organizers and speakers. Without them, this event will not be possible. And we also extend our thank to Shobhan, Prem, Nisha, and Ramakrishnan, and also our CB community members for their constant support. Yeah, hope everyone has a key takeaway today from our today's session. Yeah, thank you so much for joining.
Thank you all.
Thank you.
Thank you.
Thanks, everyone.
Thank you all.
Thank you everyone for joining and making the session.
Thank you, everyone.